Maslow, the renowned American psychologist, identified the pyramid of human needs, at the base of which are the two essentials, food and shelter. So shelter is the topic of my presentation tonight. At the dawn of the 21st century, unfortunately, this is the condition of shelter for nearly 1 billion people in our world. These slums are the breeding ground for disease, crime, illiteracy, and overpopulation. Naturally, governments are after solution. They are after finding ways to change the situation. However, what they're facing is a problem of conventional construction, the current construction methods that we employ. They are generally slow, they are labor intensive and inefficient. If you look around yourself, pretty much everything is made automatically today. Your shoes, your clothes, your home appliances, your car. The only thing we still build by hand are these buildings. Construction is the most hazardous job. It is more dangerous than mining and agriculture. In this country, it kills 10,000 people every year, and there are about 400,000 injuries every year. Eventually, these translate into cost to the society and homeowners. Construction, the way it's done today, is very wasteful and generates a lot of emission. And because of all the different trades that are involved in there and the difficulty of the management process in construction, the process is pretty corruption prone. It is very costly and is always over budget. So what we have been focusing on, finding a solution to this problem. And our solution basically benefits from advanced technology. I named this process contour crafting, and it is essentially a way of streamlining the process of construction by benefiting from the experience that we have gained in the domain of manufacturing. In manufacturing, there is a process called CAD/CAM, computer-aided design, computer-aided manufacturing. A lot of things that you see are designed on computer and without any human interference are sent to the production machinery that automatically make those products that you use. So we want to scale up those processes and bring them to the realm of construction. This, of course, has been the desire of a lot of engineers and technologists. There have been problems, there have been difficulties in such a transition. Recently, there has been development in the field of fabrication. You probably heard about 3D printing of 3D objects. So contour crafting is basically scaling up 3D printing to the scale of buildings. What we are hoping to generate are entire neighborhoods that are dignified at a fraction of the cost, at a fraction of the time, far more safely, and with architectural flexibility that would be unprecedented. So the buildings that will be built, of course, will not be as homogeneous as these. Every building can be very different. They do not have to look like tract houses because all you have to change is a computer program. The architectural design is basically sent to the machine directly. This animation shows the concept. The material, which is cementitious materials, initially concrete, is deposited through a nozzle, and the building is built layer by layer. In the process, a lot of things can be done, including automatic reinforcement, automatic plumbing, automatic electrical network installation. And once the basic structure is done, there could be other automated processes that would do auxiliary operations such as finish work, tiling, and even painting using inkjet printers, the kind that print the billboards. So in the end, the whole building can be ready in an unprecedented time. We anticipate that an average house, like 2,500 square foot house, can be built in about 20 hours, custom design. The model that you see here is pretty simplified because I didn't want to make the animation difficult for my students. But you can imagine that the walls do not have to necessarily be rectilinear. They can use any kind of curve. Therefore, you can really execute very exotic, beautiful architectural features without incurring additional cost. These clips show how reinforcement, plumbing, and electrical installation can be done. So rather than using continuous rebars, we can have segments of rebar automatically inserted and assembled inside the building. So this wall is being reinforced by a two-dimensional mesh of steel. Likewise, plumbing elements could be installed while the building is being erected. As you know, currently every one of these activities involve their own trade. So for electrical network installations, you can have these polymeric blocks with conductors that carry electricity and communication signals. Well, this is one of the machines that we've developed. As you see, the nozzle is secreting pretty dense concrete. This concrete is high performance, and it is mixed with fibers, composite fibers. It gives you a pretty good strength. This particular wall has a 10,000 psi strength. The average concrete structures that you see typically are about 3,000 psi, pounds per square inch. This wall is hollow, therefore does not use as much material. It's lighter and has good heat conduction characteristics. This is a typical machine that will be used for this technology. And this particular machine that you can see here can replace existing mobile homes. Refer to them are tornado magnets. You can have different kinds of configuration for these robots. This is like for a single detached residential building. You can have a multi-nozzle machine that will be good for large buildings. These nozzles work concurrently, or you can have the machine climb the building. Look at this old structure. This is about 200 years old. It's a beautiful adobe structure built in one of the most earthquake-prone regions of Iran, in the city of Kashan. It stands erected still after all the experiences that it has had of shaking because of the wonderful geometries that are used in here. Rectilinear walls are the worst kind of structures as far as strength is concerned. Inside, these buildings can be pretty homey, organic. And the patterns that are used for building these are pretty ingenious. But those people are no longer accessible in a lot of places in the world. And if they are, they'll be very expensive. However, with robotic system, we can mimic those patterns and build those beautiful structures automatically. And we can even use the in situ material to build structures without support beam. So our current project that is supported by NASA aims at using the technology to build lunar structures, such as landing pad, roads, hangars for the landers, support walls, radiation protection walls. So these are some of the structures that are built. This could be a lunar fuel vessel. What we expect to offer with this technology is significant reduction to the cost by reducing the cost of financing, the cost of materials, and of course, significantly reducing the cost of labor. Compared to emergency prefab modular, and conventional construction, contour crafting will offer the highest architectural flexibility with a cost that is only higher than emergency building construction today. And as far as construction speed is concerned, nothing will beat contour crafting. CO2 emission is a small fraction of the current emission, and the energy usage by the technology is also very low. So therefore, the technology is extremely environmental friendly. Contour crafting as a disruptive technology will have a number of impacts, including economic impacts, employment impacts, social impacts, regulatory, environmental, and architectural impacts. With respect to employment impact, I should just make a remark that there is a lot of concern about people being put out of the construction job. The reality is that a lot of new jobs can be created in this sector as well. You know, currently, women and the elderly do not have much opportunity to work in the construction industry. With new technologies like contour crafting, those groups of people can also be employed in more creative activities of construction. At the beginning of the previous century, around 1900, 62% of Americans were farmers. Today, less than 1.5% of them are involved. The world did not come to an end as a result of utilization of agricultural technologies. And the same will be true in case of construction. There will always be better economies resulted from advancement and utilization of technologies that just make sense. Thank you.